All right, so now we're going to get into using the formula. So here is your law of cosines formulas. The book, and this is where I got these formulas from, is your textbook. They're giving you multiple, but you really only need to know one. And just realize that, whatever you're solving for over here matches the angle over here. And then to fill in the other pieces, it's just everything else, right? So see how this side length matches this angle, and then it's just the other two pieces. This matches this angle, and then the other two pieces. Order doesn't matter because you're adding and multiplying, so you don't have to get caught up in that. The reason I mention that is because on your reference sheet, well, this is going to take me a little bit because it logged me out. So on your reference sheet, you can find under content and then your course information. So here's your reference sheet. This is what you can use on all your exams. So you can't use anything else, and this is a district-wide policy. And you'll see here with law of cosines, they're just giving you in terms of C. But again, just so you feel more comfortable, you know how to interchange the other ones. Realize that this is the only thing you can use. So maybe while you're doing your homework, you use this sheet to make yourself more familiar with it, and so it doesn't feel so foreign when you take your exams. All right. So when I'm solving for an oblique triangle, my go-to is going to be to solve using law of sines because I personally find it easier. So when I'm looking at these cases and it says when to use law of cosines, and I'm giving you these two cases, do not memorize these, all right? So let's just set this thing up. So case 3, it says you're given side, angle, side. So let's just label this any which way we want. So I'm going to be creative and do ABC. And it's saying, okay. And it doesn't say which side, but it says it gives me a side, it gives me an angle, and it gives me another side. So that is not the ambiguous case because my angle's between the two sides. So if I go ahead and I start setting up my law of sines, when I look at what's given to me, I'm going to change colors. What's given to me in this case is I have, if I look at sine of A, I don't have angle A, but I do have side length A, so that works. When I look at B, I do have the angle B, but I don't have side length B. And when I look at C, I have side length C, but not angle C. So what's happening here is there is no full ratio. There's an unknown here. There's an unknown in this ratio. And there's also an unknown in that ratio. And that's what I mean when I say if you don't have a full ratio, it forces you to use law of cosines. All right, so I'm going to switch colors here. The other thing I want to make really, really, really important, and I'm going to even make it stand out, and I'm going to ask you to even write it down, is when using law of cosines, stick to law of cosines. The reason is a lot of us will use law of cosines and then we'll get a full ratio and we'll say, sweet, we're going to move on to using law of sines because it's easier. There is an issue with law of sines, and it will become more apparent, and you will understand it more when we get further into the term. But the problem is with law of sines is it doesn't produce an obtuse angle. There is a way around it, but from years of teaching this class, I have found it's much easier just to say, when using law of cosines, stick with it. If you're interested in knowing the way around it, shoot me an email and I'll show you. But this is really, really, really important, okay? Just stick with law of cosines. All right, so let's go and put this to use. In example 1, It says solve for the following triangles. So I'm given side length of a 2, another side length of 1, and an angle 10 degrees. For me, I'm a visual learner, so I'm going to create an oblique triangle. Does not look terribly accurate. I agree with that, but I'm going to label any which way I want. It does not matter. And I'm going to fill in the pieces I have. So I have B is 10 degrees, A is 2, and C is 1. Now, let's be clear. This is not the ambiguous case, right? Because this is actually known as side, angle, side, because your angle is included between the two sides. The other reason I know it's not the ambiguous case is because your corresponding side is not given. To reiterate, you can only have 0 or 2 triangles if you're given the ambiguous case. Everything out there is one triangle. Okay, so we can force 2 triangles on everything, but that doesn't mean it's correct. So I'm going to set up law of cosines using the formula. Since I'm given B, the angle, I'm going to use the one that says B squared equals A squared plus C squared minus 2AC, cosine B. So let's fill in those pieces. I don't know B squared, but I know A squared to be 2, C to be 1, oops, I know what B is, excuse me. All right, maybe I'll put parentheses around this. Well, this is a nice one, so I can just use a calculator to calculate this for me. So I'm going to go to my calculator. I'm going to bring it side by. Okay, so let's continue solving this. I'm going to use my Desmos. So I do 2 squared plus 1 squared minus 2 times 1 times cosine, and make sure you're in degrees, 10. So I get B squared is approximately 1.06. Although I want B by itself, so I'm going to take the square root. And what I like to do there, again, I'm always going to use the full values in my calculations, but on my paper I just round so I don't have to write everything off. So take the square root of my answer. So I get about 1.03. Pay attention to instructions. They might want you to round in a different way. On our notes, I'm always going to the second decimal place. So what we found here is we found the length of B to be about 1.03. And we still need to find this angle, A, and angle C. Whatever angle you want to solve for first, be my guest and go for it. I'm just going to decide that I want to solve for A. So if I want to solve for angle A, I'm forced to use this formula. So substituting in values, I get 2 squared. I'm going to put approximately because my B I rounded on my paper. And I don't know A. That's the whole purpose of this. Now, here's the main thing. This piece and this piece are not like terms, so I cannot combine them. This A is a variable, so I can only combine like terms. So what I'm going to do is 2 squared is 4. I'm going to combine what's in the yellow. So that is, now again, to be really accurate, I'm going to go ahead and put the answer key because that's that 1.03. And I'm going to square that. And I'm going to add that to 1 squared. So I get here 2.06 minus And now I'm going to do in my next one 2 times. Well, I can't use the answer because the previous answer isn't that 1.03. But again, I'm going to just try to be as accurate as possible. So I'm going to put in as much of that decimal I see. So 1.02999364. And then I times it by 1, which we know would be the same, but just to show it. If you're in a computer, my iPad's just sensitive to cut and paste, but you can cut and paste these answers too, which is really great with Desmos. So I get 2.0. If I round correctly, that would become 2.06 cosine A. Well, again, I can't combine those, so I have to subtract this 2.06 on this side. Now remember, this is a different 0.6, which gets very confusing. So I'm going to try to highlight this to make it stand out. That's 2.06, and then that one's also 2.06, but they're different values, right? We can see that they're different. So just make sure you put in the right one. Well, remember, we got this 2.06 from 1.03 squared plus 1 squared. So that's why it's the 2.060768. And of course, you might round and get the correct answer. However, I want to make sure that I'm creating good habits with you. And sometimes, if you round too much, your answer will be very off. And sometimes not. So it's not worth the gamble. So I just always try to be as accurate as possible. So I rounded on my paper that to be 1.94. And now, again, I'm trying to isolate A, so I need to divide by negative 2.06. So I'm going to go to my next one. I'm going to do answer divided by negative. And remember that this one, let me highlight it, this negative 2.06 comes from this original piece. So if I'm looking at my calculator, which is really nice that Desmos doesn't lose anything, 2.0598728. So I get about negative 0.94 is approximately cosine of A. Now remember, we talked about when you're looking for an angle to isolate this piece, we have to take the inverse. And that's a 111 topic, and we also will go into it further in the terms. So if I take the inverse of this value, I will be left with my angle A. So I'm going to go here, go to function, inverse of cosine, and I'm going to go ahead and put in the entire answer. So I get A is approximately 160.29 degrees. Now, if you did law of sines, you would not have gotten that answer, okay? And maybe try it to convince yourself why you can't use it. So far we have our side length B, and we have angle A, and the last piece we need is angle C. Well, we know our triangle. Let's change colors, make it stand out. Our triangle adds to 180. If we take away the angle we found and the angle we were given, let's be careful with units, we will get the left over angle. I'm going to put approximately, since 160.29 was rounded. Now if I do this in my calculator, I do 180, take away, well, I'm going to take away my answer, and I'm going to take away the 10 degrees that was given to me. So I get 9.71 degrees. Now, for organization, just make sure all your work lines up, and I don't have to like check a crazy amount of work and like chicken scratch to find where all your answers are. You know, ideally you shouldn't have to box your answers because your work is so organized. Mathematicians say that because they don't want a bunch of chicken scratch everywhere and then you just make this answer stand out. Everything should be really organized. Okay, I'll see